January 23, 1943, Eglin Field Proving Ground, Florida. The temperature was 14 degrees Fahrenheit, which was very, very cold for Florida. Samuel Green watched a weapon break down for the 17th time. In just 2 hours, America's main airplane gun, the Browning M2 50 caliber machine gun, stopped working and froze on its testing stand. Steam floated up from the barrel, showing clearly how the gun stopped working in freezing temperatures. Major Robert Johnson from the Army Air Force's Armament Laboratory threw his clipboard down onto the frozen sand. He was very frustrated. "Green, this problem is very bad. Right now, 423 B-17s are flying in England, and each plane has 13 of these guns. That's 5,499 guns that will stop working the moment they fly higher than 20,000 feet. Our 8th Air Force shoots down 3.1 German planes for every plane we lose when the guns work right. When they break, our bombers can't defend themselves." Samuel Green was a 52-year-old worker from Connecticut who made tools. He never finished high school, never served in the military, and never designed weapons. He looked at the jammed machine gun with disappointment and curiosity. Army weapons experts had said the problem couldn't be fixed. Engineers from Browning Company had tried every normal way to fix it, but the weapon stayed frozen while American airmen died over Germany with guns that wouldn't work. Green took out a small notebook from his tool bag and wrote down one thought that would change how automatic weapons were built all over the world. The problem is not the gun. The problem is we are trying to make the gun work the way we think it should work, instead of letting the gun tell us how it wants to work. Major Johnson looked at the toolmaker, whose words seemed confusing. "Green, what you're saying doesn't make sense. The gun works as a machine that follows the rules of science. We have test data, engineering plans, and math formulas." Green pulled out an old metal file from his bag. "With respect, Major, your math formulas did not create this weapon. John Browning designed it by using his feelings and experience. I am a toolmaker. I understand working that way. Give me 1 week and permission to change this weapon in ways that will upset your engineers, and I will make sure it never jams again, no matter what." Neither man knew this moment would start the most argued-about change in United States military weapons history. Within 3 months, Green's unusual solution would turn the 50 caliber Browning from an unreliable weapon into the most dependable machine gun ever made. Within 6 months, his changes would save thousands of American airmen's lives. The rules of how to design automatic weapons were about to be rewritten by a toolmaker with a file and strong determination. John Moses Browning's last great creation was the Browning M2 50 caliber machine gun. Created in 1918, it had spread throughout the American military. By 1942, every heavy bomber carried several 50s. Fighter planes used them as main weapons. Ground vehicles and Navy ships had them everywhere. The United States military had made the 50 caliber its standard heavy machine gun. Fighting in battles showed a terrible problem. Above 20,000 feet, where temperatures dropped below -30 degrees Fahrenheit, the weapons broke down very often. Numbers from November and December 1942 showed a scary picture. Out of 213 B-17 missions, crews reported weapons failures on 161 missions, a 76% failure rate. Planes averaged 4.7 jammed guns out of 13 total weapons. The deaths started right away. German fighter pilots quickly figured out this weakness, attacking bombers with broken weapons. December 1942 alone saw 14 B-17s destroyed after losing all defensive weapons to malfunctions. This meant 140 airmen dead or captured just because their guns jammed. The Army Ordnance Department started serious investigations. Engineers found several causes. Gun oil became thick in extreme cold. Metal got smaller and parts fit too tight, and water vapor froze inside the parts. From October 1942 through January 1943, normal solutions were tried many times. Cold-resistant gun oils, improved ammunition sizes, heating parts, and looser clearances. Nothing worked. The .50 caliber breakdown rate stayed above 60%. $2 million produced almost no improvement. Samuel Green got involved in this crisis almost by accident. He worked as a master toolmaker at Pratt & Whitney in Hartford, Connecticut, making precise measuring tools. For 37 years, he worked 6 days a week, making tools others used to build engines. When Pratt & Whitney got a contract to make M2 machine guns, their test weapons had the same cold weather jamming. The plant manager, desperate for answers, announced a $10,000 bonus for anyone solving the problem. He said, "Every engineer looking at this weapon says the design is perfect, so the problem must be coming from somewhere else. Browning's design can't be changed. It's already perfect." Green found this way of thinking troubling. In 37 years, he had learned no design is perfect. Every machine has strange behaviors that only show up when it's being used. Math perfection and actual reliability are different things. That evening, Green looked at a failed test weapon. He took it completely apart, measuring every piece. Everything was the right size. Everything matched the plans exactly. But the weapon had failed. As he slowly put it back together, feeling how each part fit, he noticed something unusual. The bolt carrier fit very precisely in its track, but when Green manually pushed it, he felt slight resistance at certain spots. He looked at the track more carefully. The surfaces were perfectly smooth, but the track had a barely noticeable bend, less than 2/10,000ths of an inch across 12 inches, well within acceptable sizes. Green thought this tiny bend created sticking. In warm conditions, it didn't matter. In cold conditions, with thicker gun oil, it was enough to cause failure. That night in his basement workshop, Green started an experiment that would shock Army engineers. Using a precise file, he removed material from the bolt carrier, making it thinner by 3/10,000ths of an inch, which made the space bigger than the plans allowed. By engineering standards, he had ruined the weapon. By Green's thinking, he had given the bolt carrier enough room to move smoothly despite small imperfections. The next morning at the test building, the changed weapon was put in a freezer at -30°F for 4 hours, then test fired. It worked perfectly. 100 rounds, 200 rounds, 500 rounds, 0 jams. The range officer was amazed, then worried. "You changed a military weapon without permission. You changed sizes beyond what the plans allow." Green replied calmly, "The plans make a weapon that jams. My change makes a weapon that works. Which matters more?" Within hours, Green faced the plant manager and Army Ordnance officer, Captain Robert Mitchell. Captain Mitchell was angry about unauthorized changes potentially putting service members in danger, but the plant manager argued, "We should test whether the change actually works before rejecting it." Mitchell agreed to send the weapon to Eglin Field for complete testing. The weapon reached Eglin Field on January 18th. Major Johnson was doubtful but desperate. On January 23rd, in 14-degree temperatures, he set up Green's changed weapon for cold weather testing. The results were amazing. 2,000 rounds without a single jam. Put in -50 Fahrenheit for 12 hours in a cold chamber, it fired right away with no jams. Purposely covered with sand and dirt, it kept working, showing perfect function under conditions where normal weapons always failed. Johnson immediately called Green to Eglin Field to explain his change. On January 26th, Green arrived with his tools and a way of thinking that would clash badly with military engineering culture. The meeting included Green, Johnson, 3 Ordnance Department engineers from Aberdeen Proving Ground, and 2 Browning Arms representatives. The atmosphere was tense. Major Johnson opened with facts. Mr. Green's modified weapon has shown 100% reliability under conditions where standard weapons fail 60 to 70% of the time. Mr. Green, please explain exactly what you did. Green drew a simple picture showing the bolt carrier and track. I made the bolt carrier thinner by 3/10,000ths of an inch. This gives space for movement even when the track isn't perfectly straight. And cold makes everything get smaller. Standard size assumes a perfect track, but tracks aren't perfect. More space lets the bolt move smoothly despite imperfections. An Aberdeen engineer with a doctorate degree protested right away. Mr. Green, what you're describing is mechanically wrong. The specified clearances are calculated to make sure the gun cycles best. Making the clearance bigger ruins all the settings. Your change goes against basic rules of automatic weapons design. Green listened patiently, then responded in a way that shocked everyone. Sir, I don't understand your math, but I understand machines. I've worked with machines for 37 years. Your calculations say my change shouldn't work, but it does work. Maybe your calculations are wrong. The room erupted. The argument continued until Major Johnson stopped it. This debate is pointless. We have a crisis killing American airmen. Mr. Green has given us a solution. Our job is figuring out if we can do this to all M2 weapons. I'm ordering complete testing. If you're finding this story as interesting as I'm telling it, make sure to hit that subscribe button right now. Stories about the civilians who changed warfare are what this channel is all about. Don't miss the next one. Complete testing started February 1st. 20 M2 weapons from 3 manufacturers were changed by Green himself. Each went through tough testing, standard firing, cold chamber testing at -50 Fahrenheit, continuous fire of 5,000 rounds, purposely getting it dirty, and high-altitude chamber testing copying 30,000 feet. The results were the same across all 20 weapons. Cold condition breakdown rate, 0.8%. Standard, unchanged weapons, 68%. Green's change reduced cold weather breakdowns by 99%. Doing this to all military weapons presented huge obstacles. By February 1943, about 96,000 M2 weapons were being used in service, with another 60,000 being made. The Ordnance Department estimated 18 months and $12 million to change all existing weapons. Generals Leslie McNair and Henry Arnold both wanted immediate use, but the Ordnance Department demanded more testing. The paperwork standoff ended when Lieutenant General William Knudsen, Director of War Production, personally visited Eglin Field. After watching modified weapons firing perfectly, Knudsen asked Green 2 simple questions. Can trained weapon fixers do this change quickly on weapons already being used? And can production lines add this without slowing production? Green confirmed both, about 45 minutes per weapon. Production lines just machined to different sizes, no new equipment needed. Knudsen decided right away for complete use across all services. All existing weapons would get the change during normal maintenance. All production lines would add new sizes immediately. The change got the name Modification 743, but became known as Green's Fix. Putting it into use showed American industrial ability at its best. Within 1 week, detailed instructions reached every armory. Within 2 weeks, production lines added new sizes. Within 1 month, mobile change teams worked at air bases throughout the United States and England. Within 3 months, over 40,000 weapons were changed. Within 6 months, all 96,000 existing weapons had Green's change. Combat impact was immediate. March 1943, before the change, 8th Air Force bombers reported weapons breakdowns on 57% of missions. April, with 30% modified, breakdown rates dropped to 38%. By June, with nearly complete modification, breakdown rates stayed under 4%. Green's change reduced weapons failures by 94%. More importantly, bomber losses because of broken weapons dropped sharply. First quarter 1943, 14 B-17s confirmed lost after total weapons failure. Second quarter after the change, only 2 lost. The change directly saved bomber crews. German Luftwaffe pilots noticed the change. Intelligence reports from captured pilots showed they recognized American bombers' defensive fire had become more dependable. One June report noted, American gunners kept up steady fire throughout fights. The previous pattern of weapons failure had disappeared. Attacking American bombers became much more dangerous. Ground forces had similar improvements. Tank commanders reported vehicle-mounted 50s worked reliably. Infantry heavy weapons teams found their 50s needed less maintenance. The Pacific theater saw improvements in humidity and saltwater environments. Navy ships reported fewer jams during anti-aircraft fights, critical against kamikaze attacks. One particularly striking example happened November 2, 1943. Captain Robert Johnson of the 56th Fighter Group, flying a modified P-47, took cannon fire. His plane took 21 cannon hits and over 100 machine gun impacts. His guns kept firing the whole time. Army engineers later figured out that without Green's change making sure weapon reliability, Johnson probably would have died. Instead, he survived to become one of America's top aces with 27 victories. The technical legacy went beyond the M2. The principle of operational tolerance influenced all later automatic weapons design. After-war weapons, including the M60 machine gun and M16 rifle, had clearances designed for reliability rather than theoretical perfection. Green's insight became basic to American weapons development. Samuel Green got the Medal for Merit in April 1943, presented by General Arnold. The award said, "For extraordinary achievement in weapons development, specifically for creating a change to the Brownie M2 machine gun that greatly improved reliability and saved many American lives in combat." But Green stayed uncomfortable with recognition. He went to the ceremony because Arnold personally asked him to. He accepted the medal with brief thanks, turned down interviews, and returned to Hartford and his job at Pratt & Whitney. Co-workers reported Green showed the medal once, then stored it in his drawer, where it stayed until his 1951 retirement. Green got hundreds of letters from servicemen whose lives were saved by reliable weapons. He kept every letter in a wooden box in his basement. Staff Sergeant Michael Chen, a waist gunner on a B-17, wrote in July 1943, "Mr. Green, our plane ran into 6 German fighters last week. All 13 guns fired perfectly. We shot down 2 fighters and damaged 3 more. Before your change, at least half of our guns would have jammed. We would likely be dead now. Because of you, we came home. Thank you for giving us guns we can trust." Before we reach the incredible ending, I need to ask you something important. If you're enjoying this deep dive into history, hit that subscribe button and turn on notifications. Your support helps us keep bringing these stories to you. After-war military analysis showed the Ordnance Department had spent over $2 million in 5 months trying normal solutions that failed. Green succeeded in 1 week with simple tools. A 1946 War Department study figured this delay cost about 64 bomber aircraft and 640 airmen, plus countless ground casualties. The study recommended military development add ways to test unusual solutions from non-traditional sources. Green worked at Pratt & Whitney until retiring in 1956. During those 13 after-war years, he solved dozens of manufacturing problems and trained younger toolmakers. He rarely mentioned his Medal for Merit. When asked, he usually answered, "I fixed a gun that wasn't working right. That was my job. Fixing things is what toolmakers do." Green died in 1971 at age 80. His obituary was short, noting his career and Medal for Merit. It didn't mention his change had been added to over 500,000 M2 machine guns. It didn't note his operational tolerance principle influenced every American automatic weapon designed after. Green would have preferred it that way. The M2 50 caliber machine gun is still being used in service today. As of 2024, the weapon serves with United States forces and over 100 allied nations. Modern M2s still have clearances that came from Green's original change. The weapon has been in continuous production since 1921, the longest-serving machine gun in American military history. Its legendary reliability goes directly back to Green's work. Total M2 production exceeds 3 million weapons. About 2.1 million had Green's change. Everyone benefited from the insight of a toolmaker who understood that machines speak to those who listen. From World War II through Korea, Vietnam, Iraq, Afghanistan, and continuing today, American service members have depended on 50 caliber weapons that work because Samuel Green filed a bolt carrier in his basement workshop. The change method became standard training for military weapon fixers. The procedure Green developed is taught at every United States military weapon fixer school. The emphasis on functional testing over size measurement that Green supported became policy across military maintenance operations. The broader lesson is about being open to unusual solutions. The Army first resisted because it came from a person without credentials who broke the rules. Only senior leadership stepping in overcame this resistance. General Knudsen wrote in his memoir that the military must create processes for finding innovations regardless of source. Smart ideas come from unexpected places. Our job is recognizing them, not filtering them by credentials. In 1988, the Smithsonian opened an exhibit on civilian contributions to World War II military technology. Samuel Green was featured prominently with displays including his original tools, notebook, and the first modified bolt carrier. His Medal for Merit, donated by his family, was displayed alongside letters from servicemen. The exhibit attracted over 3 million visitors, bringing Green's achievement deserved recognition 17 years after his death. Modern military weapons development has formal systems inspired partly by Green's example. DARPA actively asks for unusual ideas from non-traditional sources. The Army Research Laboratory runs programs encouraging civilian engineers to tackle military challenges. The Army School teaches Green's change as an example of successful innovation from unexpected sources. The weapons community remembers Green through informal traditions. Instructors reference Green's rule when teaching modifications. Measure twice, file once, test thoroughly. The annual Green Award recognizes people who achieve big improvements through simple, practical solutions. The final assessment must recognize both how big Green's achievement was and the circumstances that made it necessary. He solved a critical problem killing American servicemen. His solution was elegant, practical, and immediately usable. But his solution was necessary only because normal processes had failed. Rigid following of specifications, rejection of unusual approaches, and bias against innovators without credentials prevented solving the crisis through normal channels. Today, whenever a 50 caliber machine gun fires reliably in Arctic cold, desert heat, or jungle humidity, that reliability goes back to Samuel Green's change. When Special Forces operators depend on their weapons in extreme conditions, they rely on principles Green established. The civilian toolmaker who never finished high school changed the most widely used heavy machine gun in military history. Samuel Green died quietly, lived modestly, and achieved lasting fame by improving one gun's function. His story shows that the most important innovations often come from unexpected sources, that practical wisdom can beat theoretical knowledge, and that solving problems matters more than following rules. The math was always simple. Standard M2 weapons had a 68% breakdown rate in cold conditions. Green-modified weapons had a 0.8% breakdown rate. The difference? Thousands of service members who came home because their guns worked, thousands of families who stayed whole, and thousands of lives saved by a civilian toolmaker with a file and the belief that working was better than perfection. The weapon displayed in the Smithsonian, serial number 432789, is a green-modified M2 that served with the 8th Air Force. It fired over 80,000 rounds in combat without a single jam. The sign describes its combat record, but doesn't mention the Connecticut toolmaker who made that record possible. But weapon fixers remember. Veterans remember. Anyone who depended on a .50 caliber machine gun that worked carries Samuel Green's legacy forward. The civilian who made America's .50 cal never jam taught lessons beyond weapons development. Sometimes the best solution goes against normal wisdom. Sometimes expertise exists without credentials. Sometimes fixing what's broken matters more than defending what's supposedly perfect. Samuel Green's impossible trick made the impossible possible. He made the most used heavy machine gun in history reliable under any condition. He saved thousands of lives. He asked for nothing except permission to fix what was broken. That is the true story of how one civilian toolmaker, working with a file and the belief that working was better than perfection, made America's .50 caliber machine gun never jam again. And in doing so, he became one of the unsung heroes who won World War II.